Hello and a good morning, good afternoon, good evening, wherever you are around the world. Welcome to today's Postgrad webinar service. Today is brought to you by Postgrad Solutions and Heriot-Watt University to hear about the MSc in Biomedical Engineering that is offered by both Heriot-Watt and the University of Edinburgh. Today's session is live. It's the 7th of May 2026. So if you have any questions and you're watching live or if you're on social media, please pop it in the question box, the Q&A box if you're on Zoom, on the chat facility on socials. And if you're watching on demand, please factor in anything that you might hear. Could be date sensitive, so things might be subject to change. It's wonderful to have you all here. It'd be great to see where you're from, so please feel free to say hi and where you're from in the chat, just so that the panelists here can get an idea and a bit of a gauge of where the audience is from, and it'd be good to see so many different faces. If you have any questions on demand, webinars at postgradsolutions.com is the place for you to email. We'll try and get your question as quickly as possible to the team at Heriot-Watt and the University of Edinburgh. Now, without wasting too much of your time, I'd like to hand you over to Maiwen. She is one of the program directors, and she is going to talk to you in more detail and introduce others about what makes this course and program such a great offering. Maiwen, over to you.
Thank you, Gareth. So a warm welcome to you all from me and on behalf of my fellow co-directors. So we have Michael Crichton, who completes the team at Heriot-Watt, and we have Adam Stokes and Lucia Bandera, who are part of the team at the University of Edinburgh. And together we bring expertise, experience, and our passion in lab on a chip and sustainable diagnostics in soft tissue mechanics, mechanical device development, bio-inspired engineering, soft robotic systems, engineering biology, and precision medicine. So the objectives of this MSc, the first one is really to bridge the gap between engineering and biology and medicine. And that's so we can address some of the world's biggest challenges. So we now live longer, but sicker. Young people have higher rates of cancers, and infections from various origins are on the rise. And also the cost of healthcare has become unsustainable. So we need engineers to understand the medical context. We need biomedical scientists to understand how to design and manufacture solutions that will accelerate the production of cheaper, more efficient, and integrated medical devices to diagnose and treat and address all these challenges. We want to broaden your knowledge of medical technologies applications, and we have a unique focus on integrated medical devices. That could be wearable technologies, that could be automated diagnostics, decentralized diagnostics, etc. We're going to teach you how to develop your design and manufacture skills to make these devices, these integrated devices and technologies. But we're also going to teach you a lot more than pure technical skills. We want you to grow your understanding of the ecosystem of medical technology development. And so we will introduce you to concepts of medical ethics, of patients' co-creations, of human factors, regulatory affairs, all of which are really important considerations in your journey to become well-rounded professionals and skills that are on demand on the job market. So we, the Heriot-Watt University and the University of Edinburgh, are partnering to offer you this program. So Heriot-Watt has set up the first Mechanics Institute. We're a very global university with campuses in Scotland, in Dubai, and Malaysia. And we bring expertise in sensing, photonics, tissue mechanics, mechanical device design to this MSc. The University of Edinburgh is a world-renowned university, over 400 years old. Its medical school was established in 1726. And our colleagues bring their expertise in sensing, bioengineering, bioelectronics, and much more. So both universities are located in the city of Edinburgh in Scotland. Um, the site where you will be taught at the University of Edinburgh is called King's Buildings and is located within the inner ring of the city of Edinburgh. And Heriot-Watt University is located outside the inner ring city in a countryside location. So I think it's fantastic way to discover the city by having this city campus, but also enjoying the countryside aspects of Edinburgh and Scotland with our beautiful and very green campus in Heriot-Watt. The distance between the two campuses about 30 to 40 minutes of public transport and a bus ride. So our student cohort is very diverse. We welcome students from a variety of engineering backgrounds, mechatronics, physics, and also life science and medical sciences. And we really want you to benefit from peer-to-peer learning. So we want you to bring the expertise, the academic expertise you have developed in your undergrad degree and share these with your colleagues, and in return also benefit from their experience and expertise in other domains. We have a set of values for this MSc. We want to be multidisciplinary, and that's why also we are bringing students from different cohorts, different discipline backgrounds. We also want to be inclusive and allow multiple perspectives in the design and development of medical devices. That means taking into account the perspective of engineers, obviously, of clinicians, but also of patients, of carers, of nurses, and anybody involved in a care pathway. And we want to be very patient-centered and not lose the fact that at the end of the day, patients need to benefit from these new medical technologies. We also want to be impact-driven. We want to equip you with the possibilities, the capacity to make a change in the world, whether it's at home or whether it is in your home country. And indeed, we have a national outlook. We work with clinicians in the national health system here in Scotland, but we also have a global outlook with a number of partners that we're working with in our research projects, but also we want to help you, make a change in your home country, if that's possible, and make this happen. So what you can expect from sort of the teaching style in this MSc. The program includes, as you might expect, some set lectures, but you will be also invited to seminars given by experts from industry, the health services, or the third sector. You will be offered laboratory demonstrations, and you'll be involved in practical exercises in labs and workshops and practical assessments as well. We try to organize industry visits where possible, but we also encourage you and we will support you to organize your own industry visits, typically things that are relevant to the projects that you're taking in this MSc program. And we will be working with clinical specialists throughout the 3 semesters. So our ecosystem, so we work closely together, Heriot-Watt and the University of Edinburgh, but we will also work in a broader context of the innovation ecosystem in Scotland, in medical technologies, so working with the NHS, working with other universities that are teaching relevant subjects, such as nursing, for example, at Edinburgh and Napier University. And we worked also with the third sector, with organization like InnoScot Health, which helps clinicians, doctors, nurses in the NHS to produce new technologies and bring them to market. And we have a range of other partners. So we receive from them projects, they give guest lectures, they offer visits, they offer research support, and in exchange we provide a skilled talent pool, and that's really yourselves, as well as ideas, solutions, and also access to research funding. So let's have a look at the program now. So in this program at a glance, you have all the mandatory courses. So please have a look at the color coding. In blue are the Heriot-Watt courses, and in green are the University of Edinburgh courses. So you have in semester 1 and 2, you have a set of mandatory courses, starting with the engineering biology interface, prototyping and manufacturing, and as well as the multidisciplinary group project, which lasts for the semester 1 as well as semester 2. And then these are happening in Heriot-Watt. And then in semester 2, you have a number of courses that are happening at Heriot-Watt or at the University of Edinburgh. And then in semester 3, you have your MSc dissertation. And then you can choose one of two optional streams. So one is the bioelectronics stream at Edinburgh, and the second one is the biomanufacture stream at Heriot-Watt University. So let's explore all of these subjects a little bit more in detail. So the engineering biology interface is really to give you some basic concepts, or for you to refresh on basic concepts of anatomy, physiology, measuring the body's activity, but also the challenges of the engineering biology interface, mapping the medical device journey from inception to disposal, as well as considering patient perspectives. And that's taught by Michael. And then you have prototyping and manufacturing for medical devices. It's really to explore how we make medical devices. And in this course, we cover advanced manufacturing technologies to make devices, which include additive, subtractive, and volume shaping technologies. And we also touch upon things like AI, the use of artificial intelligence in manufacturing, characterization methods, and some biomimetism concepts as well. So the multidisciplinary group design project is the course that covers both semester 1 and semester 2. So in this exciting course that's also led by Michael, you will be essentially receiving a brief from a clinician, and you will be working in groups to engineer a solution to answer that brief and create a pathway to manufacturing and putting this device in commercial use. And in these projects, you can expect interactions with patients, with clinicians, and other stakeholders that are involved throughout the life cycle of the device. And it's really to give you the capacity to develop medical technologies. In technology to entrepreneurship, that's happening at Edinburgh in semester 2, you are given this entrepreneurship in the context of healthcare technology development. You will be covering product strategies and technology development strategy as well. The research methods and critical analysis is a course that you take at Heriot-Watt, and it's really in preparation to your dissertation project. So this course helps you acquire skills to undertake research, to understand how to do a literature review, how to start on technical writing, and how to do your project scoping for your final dissertation project. And finally, the dissertation project is your major personal research component. So you will be assigned a supervisor at Heriot-Watt and a supervisor at Edinburgh, and the project itself will be either in Edinburgh or in Heriot-Watt. This might depend on the optional stream that you have decided. And now we're going to go over the bioelectronics stream, and I invite Adam to come on the screen and cover what are the bioelectronics courses at Edinburgh.
Thanks, Myvan. Yeah, hi everyone. Looking forward to talking you through some of the bioelectronics courses. So bioelectronics is a 20 credit course that we teach at Edinburgh. And it covers basically everything where electronics and biology intersect. So one of the major topics we talk about is to do with biosensors. So this would be looking at things like diabetic blood glucose monitors and understanding the electrochemistry of how those things work and how we fabricate them, how you do systems design. And then more broadly, what we do in bioelectronics is we talk about medical device design, we talk about really just a really broad range of introductory topics. We don't expect anybody to have a background in biology or chemistry to start this course, so there's quite a lead-in to sort of get up to speed with the chemistry and the biology, but everybody does well with it and they thoroughly enjoy it. Then moving on from the first semester into the second semester courses, then we have two more specific courses. So one of them is on sensors and instrumentation. So this takes some of the concepts that we introduced in bioelectronics and then starts to look more at the techniques that are required for sensing in terms of the electronics, the circuit design, different types of transducers. We look at MEMS, we look at a range of different sensing methods. And really that goes into much more depth than the introductory component that we did in bioelectronics. And then we have a specific course again in second semester on lab and chip technologies. And here what we do is we look at the field of microfluidics and we look at areas where we can start to build chip level designs where we move very small amounts of fluid around on chips to then bring in functions like biosensing to be able to make measurements, to do diagnostics. And really what a lot of that course is about is the intersection of electronics and fluid dynamics and what happens at the small scale and what happens at small scale fluid dynamics and how we exploit some of those properties to build very sort of small scale lab on a chip systems.
Thank you very much, Adam.
Yeah.
So now let's look at the courses that we have in the biomanufacture stream at Heriot-Watt. So we have technologies for biosystem. So in these, you're really exploring what detection technologies are used for point-of-care diagnostics and why and when to use one or the others. You're looking at how sensors are embedded and turned into wearable devices. And you're really covering various sort of detection modalities, looking at optical detection, mechanical sensing, as well as electrochemical sensing. And you do have a practical element to these, and there is a lab on electrochemical sensing. Then we have a course on biomaterials. And here you're really answering questions as in, could you print a human organ? You will be exploring concepts around the manufacture of complex biomaterials, exploring concepts of bioprinting quite in depth, and you're also looking at new concepts of organ-on-a-chip devices and how they're used in biomedical applications. And finally, you have a course on regulation of the safe and sustainable development of substances. So this is really looking at regulatory affairs and how we can make safe devices and materials that are going to be used on humans. This course has elements of toxicology and safety of substances, and it includes a lot of experts, academic experts, as well as industry experts and guest speakers. So that's it. We've covered the depth and breadth of the different mandatory and optional courses at Heriot-Watt and the University of Edinburgh. So if you have any questions on this, you can ask them in the chat or you can contact us later. I want to say that depending on your backgrounds, you might be offered both the bioelectronics stream and the biomanufacturing stream, but in some cases, because of your background, you will be limited to one of the other options. Thank you. Okay, let's see what we have next. So we're often asked by students, by candidates, what the certificate will look like. So this is a sample of your degree certificate, and you can see that you have the crest of both Heriot-Watt University and the University of Edinburgh, and there is the signature of both principals at Heriot-Watt and the University of Edinburgh. So we're also often asked, what sort of careers the graduates will go on to do. So obviously we do not have statistics yet because the program is very new, but we anticipate that if you take this MSc, you would obtain R&D positions in medical technologies. That might include jobs in the private sector, medical device company, pharma and biotech companies, and also design consultancies. But these R&D positions could also be obtained in academic or in government research institutes, or maybe even the third sector in NGOs and charities. You might also use the program to enroll in further academic studies at the end of the MSc and, for example, take a PhD or maybe even an MD. You might want to go on a role in government and being a charity or policy advisors in medical technologies. You might take a role as a medical physicist or clinical engineers in health systems, whether in the UK or abroad. You might also want to use this course to become an entrepreneur. And indeed, this is really a pathway that we will encourage throughout the MSc, and really a pathway that we expect some of our students will take. There is a fantastic ecosystem in Edinburgh to support entrepreneurship in healthcare technologies, and so we will be pointing you in the right directions if that's what you want to do. And finally, you could also take regulatory roles in private, government, or third sector. So let's have a look at what kind of facilities we offer. So we have state-of-the-art teaching labs that offer a range of equipment for medical device rapid prototyping, assembly, and testing. From CAD design, we have 3D printers, laser plotters, and equipment for mechanical testing and electronics testing. And in this photo, you can see some of the students from the current cohort who are building from scratch a bioprinter, and that's happening in my course on manufacturing and prototyping medical devices in the first semester at Heriot-Watt. We have state-of-the-art research labs in Heriot-Watt and in the University of Edinburgh, and they're typically accessible during projects. So they include a range of equipment for medical device development, including equipment for electrochemistry, photonics, micromechanical testing, imaging, including STM and CT imaging, as well as micro and nano manufacturing. And that's a student in my lab. We have a unique facility, which we call the immersive suites. This is a room that can be set up to mimic any number of medical-related environments, including hospital, care homes, even prison and home settings. There is a projection system that can be tailored to suit, any of these environments. And it really provides an ideal setting to test health and care technologies equipment and really anticipate scenarios with the patients, with the carers and the clinical team. And that's a facility that enables partnership with patients, with clinicians, and enable preclinical testing before devices will go on and be used in the NHS or other health systems. So you will get a visit of this suite during one of the courses, and you will be encouraged to use also the suites, maybe in one of your group project or maybe in your MSc project. So this is available at Heriot-Watt. We have another unique facility called the Medical Device Manufacturing Center. It's really a unique center in Scotland with state-of-the-art equipment and expertise for medical device manufacturing, including microinjection molding and laser engraving. And there is, so this is hosted by Heriot-Watt, but includes many universities, including the University of Edinburgh and the University of Glasgow and others. And it's really a hotbed for academia and industry collaboration. You will be also given a visit, a tour of the facilities and the various equipments, and you'll be taught what are the application for each of these manufacturing equipment, etc., and exemplar projects, and you might be able to use it during your own project. The National Robotium is a flagship institution between the University of Edinburgh and Heriot-Watt University. This is the home of automation in Scotland, and it includes a number of relevant facilities also for health and care technologies. In the another immersive suite in the form of an apartment that is kitted with diverse sort of robotic facility and enables to study how robots can influence the health of patients in remission or maybe aging, etc. So again, you'll be given a tour of the National Robotium, and you may work with the National Robotium in your project. So moving on from facilities to the life in Edinburgh. Edinburgh is an absolutely fantastic city. It's very historic. It's a world famous city with a lot of heritage, but it's also highly international. It's very diverse. It's really well connected to the main airport hubs in the world. It's a true student city. Heriot-Watt and the University of Edinburgh are just 2 universities out of 4 in total in Edinburgh. And it's really vibrant city. We have since 1947 the Edinburgh Festival in August, as well as the Fringe, which also brings people from all over the world and makes life in the city very exciting. It's a really safe and very high quality of life city and has been consistently ranked amongst the best cities to live in Europe. And in all of these attributes, it provides balanced living cost compared to sort of major international capitals in Europe. So it really combines a lot of exciting features, culture, diversity, safety, and multiple opportunities. And we can 100% guarantee that you will love living in this city. All right, so now we'll move to something a little bit different. We wanted to give you a flavor of different projects that we as academic have been involved in. So I will start, and then I will hand over to my colleagues to present you, some of the things that they've been personally involved in. So the project that I wanted to share with you today is MicroSnare. It's a current project which look at the automated enrichment of circulating tumor DNA for improved cancer treatment. So let me sort of break down these for you a little bit. So this is a project that I'm running with a colleague, Nick Leslie, who is a cancer biologist, and also with a breast cancer surgeon in Edinburgh. So I've always been fascinated by cell-free DNA, which is all the DNA that we have outside the nucleus of our cells. And cell-free DNA mostly originate from our human cells, but it also originates from tumors, from fetuses in pregnant women, from organ donors in transplant patients, and even from pathogens circulating in our bodies. And in particular, circulating tumor DNA can be used to diagnose cancer earlier than if you were using tissue biopsies, which can be more invasive as well as scary for the patients. And the problem is that there is little circulating tumor DNA in the blood sample. And so the signal from circulating tumor DNA is hidden by the sort of normal human DNA. So in this project, we're using a combination of biochemistry as well as automation in order to reduce the background of human DNA versus tumor DNA, and that would make the whole analysis cheaper and more accessible. So we're using two types of automation, a microfluidic chip, which you can see here at the bottom right, and that really helps miniaturize the assay, and it could help offering it in decentralized settings and possibly at a cheaper rate as well. And we're also testing a robotic approach with a fluid handling robot or liquid handling robots that you can see on the left. And that's because it's used more and more in the pharma and in diagnostic industry. But we're also interested in the combination of these two technologies, the microfluidic chip and the fluid handling robotic platforms, because it could unlock key limitations in throughput as well as functionalities. And we will be very soon testing these technologies on cancer patient samples and hopefully making an impact on cancer patients themselves. So hopefully that gives a flavor of the type of activity that I'm involved in. And now I will pass to my colleague, Michael, to give you an idea of what he's working on at the moment.
Good morning, everyone. Really nice to connect with you all, and thank you, Maiwen, for the introduction. I think Maiwen's covered everything beautifully. I think what's nice for me to be able to share is some of the research that we've been doing. So as Maiwen mentioned, I lead on a couple of the courses. What I do in my lab is really try and understand how soft tissues like skin and muscle organs change with disease. And I take a slightly different approach than what most people take. So you get a lot of people working in the sort of biomarkers, biological aspects, and trying to understand how these tissues will create different markers if there's something physiological going on in the body. I do something which I would say in some ways is simpler, but I look at the mechanical material changes of the tissues. And that way we can try to develop new sensors that use techniques that are more traditionally engineering approaches, but that are also applicable across to clinical settings. So this work that's on the screen here, this is work we've been doing for about 8 or 9 years. Essentially, we've been developing a sensor that can measure the material changes in your skin and can measure in a few seconds what the elastic and viscoelastic properties of your epidermis and dermis in the skin are. Now, the benefit of this is that when you take these measurements, you can actually tell if skin is improving or getting worse. And this is really important for people who have skin conditions like eczema or psoriasis, where at the moment all clinicians can do is look at the skin and say, yes, it looks like it's getting better, or no, it looks like it's getting worse. So we're trying to bring objective quantitative measures for skin health into the clinic and also out of the clinic. So taking our technology and taking it into the community, so pharmacies and also into physicians' offices. So this is something we've been working on, and ultimately there are a lot of quite interesting aspects to this, and I've shared a lot of this with the students we have this year on the program, so that they can have a good understanding of the types of approach we take. But we're also commercializing this at the moment, trying to take it into the clinic, trying to turn it into a company. And this brings its own challenges. So things like regulatory challenges, needing to make sure you have a product people want, removing risk as much as possible, and undertaking clinical trials. So hopefully this type of thing is something that's quite exciting and interesting to be able to give you an example of the type of work that we do in my lab. I'll pass to you,
Thank you very much. Thank you very much, Michael. And now for something different with Adam.
Okay, hi everyone. So I thought I'd give you a slightly different flavor of things by talking about a student project. So this is a project that an undergraduate student of mine took last year. And the reason for bringing it to you to talk to you about it is really just to sort of give you an idea of the sorts of things that we might expect our students to be able to achieve in a project on this program. So really what the student was doing is they were working on something called a self-driving lab. And self-driving labs are autonomous experimental platforms which combine lab automation and robotics and AI in order to be able to plan and execute and analyze experiments in a closed loop with minimal human supervision. And the thing that I like about what happened in this project is that the student was given a brief to try and develop a new type of liquid handling robot, and they built the entire system end to end by a combination of looking at new methods for coding, for doing 3D printing, for building the electronics. And in the end, what they were able to do was to have a natural language interface for the robot to ask it to perform an experiment. And then the robot interprets that, develops all of the code, runs the experiment. And this was done in just a few months. And I think I think for me, it's quite a nice example of looking at some of the current trends that are happening in bioelectronics and biomedicine, and also looking at how the new tools and techniques that we have available to us, which certainly weren't around when I was an undergraduate, really amplify the students' ability to be able to do some really, really interesting projects. So essentially what you have here is something which was originally a 3D printer, and the student built every aspect of this, from the software to the AI interface, the machine control, the 3D printed components, the syringe pump. And at the end of the whole video, what you're able to see is that the robot performs a simple dilution assay. So the interface with the robot was simply, please take the liquid that's in one of the wells and perform a dilution assay to dilute it down to different levels. And that's the only input to the machine, and everything else happens through the combination of AI methods and machine control. So I think it's quite interesting, and what it leads to is a sort of a way of starting to think about the way that labs are going to work in the future with full sort of autonomy and self-driving. And these things will be the sort of strategic research infrastructure that it's likely that we will all be working with in the next 5-10 years. So I just thought it was interesting, mainly from the point of view of it being an entirely self-led student project, and it's the sort of thing which I would expect good students to be able to do. So I'll leave it there, Marvin.
Thank you very much, Adam. That's fantastic. And you know what? I think I need to give you our enrichment assay to try on your robot. What do you think?
We'll get a student project for this year to do it. Absolutely.
Okay. And finally, I will invite Lucia to present her project. Thank you.
Hi, everyone, and thank you, Maiwen. So here, cycling back to what Maiwen mentioned about our attempt to try and find solutions to challenges that we are facing worldwide. And here I'm presenting a little bit of the work that we have been doing on the design of therapies for chronic diseases. Now, you might know that chronic diseases are conditions that are becoming more frequent just because of the aging population. And they are diseases that are long-term and require ongoing medical attention, or they might restrict the ability of patients to perform their daily activities. Now, we were focusing specifically on a liver disease that is currently affecting almost a third of the adult population worldwide. And it is a very complex disease for which patients that manifest in an heterogeneous way within patients. Therefore, it is strictly required for us to focus on the need of subgroup of patients. And we are trying to do this by integrating data from patients into the design of therapies with an approach that is based on cybergenetics. So once again, robotics interfacing with biological systems. And we do have a controller that you can see at the top here in the slides that is acquiring data on a model, on a cell-based model of the disease. It is measuring and comparing the signals from this model with a model of a healthy patient, and it is using the distance between these two models to identify which is the action that we need to perform on our disease model in order to bring it back to physiology. And this action, of course, corresponds to a combination of drugs, for example. So here, students have been involved in projects on various points of this loop. We had a student working on designing a microfluidic platform that allows us to measure the behavior, measure and quantify the behavior of multiple cellular model at once. And here you can also see in the middle, the red and green traces demonstrate the ability of the device to administer to cells growing within it time-varying signals that are independently controlled. And we have had students working instead on in vitro model of disease. So in this case, they've been looking at patient data and extrapolating from them which is the composition, the cell compositions that is needed for these models. And then they've been using design of experiments, for example, to try and identify which is the environmental cue that needs to be provided to these cells so that they maximally resemble what we observe in patients. And all of these works has been done in collaboration with the School of Medicine based in Edinburgh, but also with colleagues across Europe to make sure that what we have are model representative of population of the wide population instead of looking at single pockets of subpatients. And I will leave it at there. Thank you, Maiwen.
Thank you very much, Lucia. That's really exciting and very multidisciplinary example as well. Okay, so my last slide today is for me to give you an update on the scholarships that are available in conjunction with taking this MSc in Biomedical Engineering. So we have the Heriot-Watt Future Shaper Scholarship. These are high value and designed to help future students who want to research and solve real world issues. It is for UK fees only. So if you're not entitled to UK fees, you can't apply for this one. But if you are, please submit your application by 29th of May. Then we have the American Friends of Heriot-Watt Biomedical Engineering Scholarship. And this is a scholarship that is dedicated solely to our MSc Biomedical Engineering program, and it is open to everyone, so open to international students as well as UK students. For benefiting for this, you need to demonstrate a need, and you also need to demonstrate your ambition to change the world. And this is closing really soon in just 10 days. So make sure that you go on Heriot-Watt page, on the scholarship page, and find the American Friends scholarship and apply. You can only apply if you've already applied for the MSc itself, but I think that's the case of all of you joining today. And finally, there is also a third scholarship, the MSc scholarship in digital health and social care, which is offered by DHR in partnership with Heriot-Watt. So this is for Scottish residency only. So it could be people who are not British or Scottish citizen, but have been living in Scotland for a certain number of years. It is not available as of yet, but we do hope to announce it later this year. So please keep a tab on us on social media, the academic on social media, as well as at Heriot-Watt's social media, where you will find some information. And I'm sure our scholarship officer would also reach out and if you were eligible and let you know. So that's it. I'm going to hand back over to Gareth, who will handle the Q&A session. But thank you very much for your attention so far.
Indeed. Thank you, Mai Wen. Thank you very much. And to all those that have participated as well. A lot of detail in that presentation, a lot of questions have come in. I'm going to start with the broader questions, if that's okay, Mai Wen. A lot of, not confusion, but I would say uncertainty in terms of what a student can expect, um, or what they need to study at a master's level, perhaps, pre-master's level, sorry, to be enrolled onto this program. Obviously, we see such a broad range of topics there. We've seen um, all things from muscular to genuine engineering to medical engineering, biomedical engineering. What would you expect a student at a bachelor's level to have that background with to then go on and do this master's, whatever it might be that they do?
Yes, Gareth, we accept a variety of engineering backgrounds, general engineering, mechanical engineering, mechatronics, as well as, people with a background in physics. But we also expect, students with a life science degree or a biomedical sciences degree. So we canvas broad. So students, should really, ask the enrollment team about this, because we're quite broad in, in terms of the background that we accept, and the idea is really to encourage peer-to-peer learning, and students, are then taking the courses, and obviously they will be more comfortable, in some of the material that is taught, and will have to put more effort in some others. But our courses are typically multidisciplinary, and they can be taken by people with different discipline background. I hope that
Uh,
helps.
Yeah, I'm pleased you mentioned that because one of the things that struck me watching this session was it's very much peer to peer. You learn from other people, but it's very individual also, isn't it? So it's quite an independent program. You can, if you're one of those that like to get on with it yourself and find out, different pieces of research and gain your education quietly, then you can do so. And also if you want to, you know, live and breathe it and understand what other people think and believe and what they think is right, then you can also do that. So I think that's an important point. Let's keep going through the questions that have come in, that are probably relevant. Does one aspect of what we've spoken about today have a higher ceiling than the other? So I think what they're probably asking here is if they were to take a specific discipline within biomedical engineering, will it perhaps put you in better stead than perhaps another one?
Um, I think so. If students want to take the bioelectronics stream at the University of Edinburgh, so the optional bioelectronics stream, they do need to have some electronics in their curriculum before, so have done some electronics in in their bachelor. Um, and so maybe that's the sort of higher ceiling that this candidate is mentioning.
Yeah, of course. Okay, let's keep skipping through them then and having a look. In terms of we go back through it, is computer science considered a relevant undergrad degree? Again, I go back to what you mentioned a moment ago. It probably depends on what they're looking to do with that. Is that fair?
Yes, so we're often asked these. Computer science is a little bit on the periphery of the sort of profile of students that we're interested in. But if they have done some engineering, if they can demonstrate things like they can do CAD drawings, they have assembled things before, and if they can demonstrate a genuine interest in biomedical technologies, then we would consider. So it's one of these backgrounds that um, the recruitment team would come to us, the academics, and ask, do you think this student is well suited? So it's one of these sort of a little bit frontiers profile of students. So I'm not saying no, but I'm not saying yes either. It's on a case by case basis.
Yeah, I think that's important. I'm going to keep on this topic if that's okay. I mean, Adam answered a question the Q&A earlier, someone asked, are there any specific engineering courses prerequisites? For example, I have bioelectrics. Do I need to have taken fluids? And Adam did answer, no, you just need to be have the willingness to work hard. And I think that goes back to the input, isn't it? Whatever you decide to put into it, you'll get out of it.
Yes, indeed. And the program, is really, vibrant, and you get to talk to a lot of people in different disciplines. And for me, an MSc program is about broadening your horizon and, networking and really understanding, what people do for a living and how they do it. And really, this true meaningful engagement is super motivating, and, you will achieve a lot more than you thought you could.
Excellent. Question to come in also about the joint venture with Edinburgh and Heriot-Watt. I think it's important for students to remember that Heriot-Watt is in Edinburgh. So they're not far away from each other, although Edinburgh's a lovely city. It's not huge. It's a nice city. It's not, it's a very friendly city. Do they get access to all the facilities at the University of Edinburgh also, as well as the likes of the Robotarium and things like that?
Yes, absolutely. The students are registered as students both at Heriot-Watt and the University of Edinburgh, so they get access to, all of the student services at Heriot-Watt and all of the student services in Edinburgh. Now, you mentioned the National Robotarium. Not everybody can enter the National Robotarium. This is arranged on, a case-by-case basis, but because you are students in this program, we will arrange a visit for you of the National Robotarium, and it's possible that some of the projects that are offered for the MSc dissertation are in partnership with the Robotarium. I don't know, maybe if Adam wants to mention anything more on the National Robotarium.
Yeah, I could talk to you about the Robotarium for a moment. So the Robotarium is a facility which is the sort of UK's National Centre of Excellence in Robotics. So if your project happened to involve robotics and you had a supervisor who was affiliated with the Robotarium, then it's certainly something which you could use. There's lots of facilities there for prototyping and for manufacturing. And it would just depend on what the project was. More broadly on that point about access to facilities across the universities, it just depends on what it is that you want to do. But what I say to students is that you can do basically almost anything you want. In terms of the facilities that you would require, we would make them available if they were needed for the project that you were taking. But as Myvan said, access to all of the facilities, student services, student unions, buildings, etc., across both universities, that's open to anybody who would like to access them.
Excellent, thank you. Mywan, if we can talk about the post-graduation aspect of things, what can a student expect to go into? So they've graduated, they've got their masters. What typically do you expect to see from a student once that has happened? Do they go straight into a job, or do they do further research?
I think there will be, a mix of these things, Gareth. Some students will go straight, into industry,
Yeah.
and some students will have enjoyed the research aspects that also are communicated in the MSc and will want to do a little bit more. So they might take, maybe a research internship, maybe they might work as a research assistant for a while in our universities or others. So I expect there will be students who know they want to go to industry, and students who don't know might linger a little bit more in academia. Some people will go straight, they know they want to do academic research and they will go straight into a PhD. So yeah, a range of these things will happen for sure.
And one question for me to kind of finish on as well, with the research intensifying all over the world and facilities getting better, there's always new things and evolving. How do you, as a program director, as a program itself, keep up to date with all the relevant things that are happening? Obviously, you've got the facilities, which is amazing, but how does the education differ year on year, month on month, depending on, what's been found, what's new, what's different?
That's a great question, Gareth. We're all really passionate about our subjects. We are not working in isolation. All of us have our own professional networks. This might be a combination of networks in industry, in clinical activities, and so we talk all the time to people, to patients, to clinicians, and to engineers and scientists in a variety of discipline, and that's how we keep up to date, by attending conferences, etc. And we're all passionate about bringing the insights that we get from these interactions back to the students, and communicate the last most up-to-date things to the students. I think I speak on behalf of all of my colleagues, that we're really passionate to give the most up-to-date information to our students. So hopefully
Excellent.
that's reassuring.
I think that's a lovely way to finish on. I think it's so important to remember that it's probably new for you. Every day you come in is probably different for you as well, and seeing different people, hearing different opinions, seeing different research and different things that are evolving. So exciting times. Thank you for your time, my Wen. Thank you for all the questions you've answered and for going through the presentation. To those in the background, Adam, and to Lucia also, and to Michael, thank you for your time. Really appreciated. If anyone has any questions today, please pop it to webinars@postgradsolutions.com. Everyone watching today, if you would like a certificate of attendance, please email ourselves, webinars@postgradsolutions.com, titled the name of the session that you've watched today, which is Heriot-Watt Biomedical Engineering, and we will send you a certificate to confirm you have watched this. For now, thank you very much, all of you watching in the background. Thank you for watching the panel. Thank you for participating. We look forward to seeing you again soon. Get applying for September 2026, if not onwards from there, September 2027, and let us know if you have any issues. Take care. Bye-bye.